Hello, everyone. Welcome back to Z. Today, we're delving into the fascinating realm of Earth's dynamics as we explore the question, how does Earth rotation happen? It's a fundamental aspect of our planet's existence, and understanding it unlocks the secrets behind day and night. So, let's dive in and unravel the mysteries together. So, what exactly is Earth's rotation? Well, it's the spinning of our planet around its own axis. The Earth's axis is an imaginary line that runs from the North Pole to the South Pole, passing through the center of the Earth. This rotation is what gives us the cycle of day and night. As Earth rotates, different parts of the planet are exposed to the sun's light. When a particular location faces the sun, it experiences daylight, while the opposite side is in darkness, creating night. This rotation takes approximately 24 hours, giving us a full day. Now, let's explore what influences Earth's rotation. The primary factor is the conservation of angular momentum. When the solar system was forming, the swirling gas and dust that composed it caused the protoplanetary disk to spin. As this material came together to form planets, including Earth, this initial spin was preserved, leading to our planet's rotation. The rotation of Earth has some fascinating effects. One notable phenomenon is the Coriolis effect, which results from the rotation causing moving objects, like air masses or ocean currents, to curve. This effect plays a crucial role in shaping global wind patterns and ocean currents. What is the Earth's rotational speed? Ever pondered the mechanism behind Earth's rotation? Without realizing it, we wake up every day, go to work, spend time with our friends and family, and go about our lives as usual without giving our planet's continuous rotation any thought. To learn more about Earth's rotation, we are going to space in this video. Now put on your spacesuit and begin the countdown as we go to the stars to discover the mechanism and cause of our planet's rotation. Let's first determine why the Earth rotates. Because of its formation, Earth rotates. About 4.6 billion years ago, a massive cloud of gas and dust began to fall under the force of gravity, giving rise to our solar system. A portion of the material inside the collapsing cloud coalesced into whirling eddies and eventually became planets when the cloud began to spin. The planets continued to spin as they formed, much like skaters who draw in their arms to accelerate their spin. The material spun faster as it gathered closer together to form a planet similar to Earth. Since there are no forces operating to stop it, the Earth continues to rotate. An axis is an imaginary line that passes across both the North and South poles as it passes through the center of the Earth. Similar to how a top spins on its spindle, Earth spins on its axis. We refer to this spinning motion as Earth's rotation. In addition to rotating on its axis, the Earth also circles or rotates around the Sun. We refer to this movement as a revolution. Since a pendulum that is already in motion won't stop, neither should the direction of its swing. But renowned French physicist Léon Foucault noted that his pendulum did appear to shift in direction. He came to the conclusion that the Earth was moving beneath the pendulum since he was aware that the pendulum could not alter its course. It takes 23 hours, 56 minutes, and 4 seconds for Earth to complete one full rotation on its axis, as observed by a space observer. However, Earth must rotate somewhat further to attain the same location in relation to the Sun since the planet orbits the star at the same time as it rotates. As a result, a day on Earth consists of 24 hours. The speed at which the Earth revolves is around 1,700 kilometers per hour at the equator and almost zero at the poles. It takes 365.24 days for Earth to complete one full rotation around the Sun. A year is defined as this length of time. Earth and the other planets remain in their orbits around the Sun because of its gravitational pull. Because Earth's orbital path is elliptical, like that of the other planets, there are periods when the planet is farther from the Sun than at other times. On July 4th, Earth comes the closest to the Sun by 152 million kilometers. The seasons on Earth have nothing to do with Earth's eccentric orbit. The average distance traveled by Earth during a revolution around the Sun is approximately 150 million kilometers. The average speed at which Earth orbits the Sun is approximately 27 kilometers per second, or 17 miles per second, however this speed varies. At aphelion, the planet moves more slowly, at perihelion, it moves more quickly. Because Earth is tilted 23.5 degrees on its axis, it experiences seasons, as does every planet. The North Pole is tilted away from the Sun during the winter months in the northern hemisphere and toward the Sun during the summer. You're probably wondering why you don't feel the Earth move with all these rotations and revolutions. The explanation is straightforward: Earth moves quickly. Its rotational speed is around 1,000 miles per hour, while its orbital speed around the Sun is approximately 67,000 miles per hour. These speeds are constant, thus we do not perceive any motion. We do not experience any acceleration or deceleration since the Earth's rotational and orbital velocities remain constant. Only when your speed changes can you sense motion. You won't feel much motion, for instance, if you are traveling at a steady speed over a smooth surface in an automobile. You do, however, feel motion when the automobile accelerates or when the brakes are used. In other words, we don't perceive the Earth's rotation or speed because we are accustomed to it. We also need to discuss how Earth's rotation has slowed down over time. Tidal acceleration caused by Earth's gravitational interactions with the Moon has slowed Earth's rotation considerably over millions of years. Day length estimations provide actual evidence for this slow rotational slowdown. According to these measurements, the day's duration has gradually extended from roughly 21 hours to the current 24 hours. Because of the unusually high rate of tidal deceleration that exists today, Earth's rotational velocity must have slowed down more slowly in the past. About 600 million years ago, rotational deceleration increased sharply, according to empirical data. Because of the reduction of Earth's moment of inertia produced by some recent large-scale catastrophes, like the 2004 Indian Ocean earthquake, the duration of a day has shortened by 3 microseconds. Earth's mass distribution is shifting due to postglacial rebound, which is the increase of land masses following the removal of the massive weight of ice sheets during the last glacial epoch. This has an impact on Earth's moment of inertia and rotation period. Man-made constructions can also affect how long the day is. For instance, NASA scientists found that the water held in the Three Gorges Dam has caused a 0.06 microsecond increase in the duration of a day on Earth. Let's review the topics we covered in this video immediately. A nebula, a cloud of gas, is what gave rise to our solar system when a lot of gas and dust gravitationally gathered together. Already, the gas and dust were circling one another. These new things began to spin, and then spin even faster, until it all came together to form the Sun and the planets. A spinning item spins faster as its mass is increased. It's similar to how a ballerina or ice skater brings in their arms to spin more quickly. So the Earth's rotation accelerated when all of the boulders and the gas and dust cluster began to converge. We've now discussed the causes of the Earth's rotation, including its acceleration and deceleration. How does it continue to rotate, though? Consider a spinning top that you have given more energy to by hand starting the spin. It eventually stops because friction from the ground it is spinning on is removing energy from the toy top. Friction is the loss of energy caused by something rubbing or dragging against an object. Have you ever dragged your foot on the ground when cycling downhill and slowed down? Friction is that. Fidget spinner toys spin for a very long time since they have less friction. Imagine the Earth floating in space. Unless anything slows it down, it will continue to spin. The Earth is so large that it would require a great deal of energy to slow it down while it is spinning. The Earth won't slow it down since it's not rotating on it. No air exists outside of our atmosphere to slow things down. And there you have it. The Earth's rotation is a fundamental force that shapes our planet's daily rhythm. From day and night to the Coriolis effect, it's a dynamic dance that has been ongoing for billions of years. If you enjoyed this exploration of Earth's rotation, don't forget to hit the like button, subscribe for more science content, and leave your comments below. Until next time, stay curious.